So continue this thought a little bit further. Let's define the concept of latent heat, right? Water has high latent heat. Latent, as you know from the word latent in English, that is something that is hidden, for example, loosely speaking. So it's the heat absorbed or released when a change of state happens. When you go from water to, let's say, snow or ice, there is some energy that is taken out of the water to freeze it. So it is the energy that is now hidden in ice or snow. Or when you convert water into water vapor or steam, you have added some energy, so there is some energy hidden there. So when you see clouds, that is water that's been converted into water vapor, so it has taken some energy into it, and when it condenses into rain, it's going to release that heat, right? These are the latent heats, and the water's latent heat is related to its high heat capacity. We said water has a very high heat capacity, so the latent heat that is hidden in various forms, various states of water is this latent heat. So here is an example which is showing temperature on the axis here, on the vertical axis, and amount of energy in calories on the horizontal axis. So we're starting at a temperature of minus 40 degrees. We are keeping the pressure at sea level pressure here, no high pressure system. So if you have sea level pressure and you have temperature of minus 40 degrees, obviously the water is frozen solid and it's ice. If you keep adding heat to it, when you add 20 calories, remember the heat capacity of ice is 0.5 joules per gram per degree centigrade. So you add 20 calories, the ice is going to warm, but it's not going to melt. It's just going to go from minus 40 degrees centigrade to 0 degrees centigrade. So 0 degrees centigrade, it's still frozen, it's still ice, but its temperature has changed from minus 40 to 0. You keep adding more energy to ice. It takes 80 calories per gram of ice to melt it, right? That is the latent heat of melting ice. That's also the latent heat of freezing. So ice is going to become water at 0 degrees centigrade when you give it 80 calories at 0 degrees centigrade. So it's still at 0 degrees centigrade, but you have added enough energy that you have melted it now, right? You continue to add energy. How much energy do we need to go to 100 degrees? We have the definition that water takes 1 calorie per gram to raise its temperature by 1 degree. So if you want to raise it by 100 degrees to boiling temperature, obviously you add 100 calories. So you go from 0 degree water to 100 degree water if you add another 100 calories to it. Now water is boiling, but it's at 100 degrees. You want to vaporize it. The latent heat of vaporization of water is 540 calories per gram. That's a lot of energy. Think about it. Just for 1 gram of water to be vaporized, you need 540 calories. And we will see why this is critical. When we think about things like desalination, you will see that this is a lot of energy. Okay? So if you add 540 calories for 1 gram of water, you're going to vaporize it. And if you keep adding more energy, you can have superheated steam. For example, when you go and buy a cup of coffee from a place like Starbucks, sometimes they give you coffee or tea that is superheated. So depending on the pressure, you can create water greater than 100 degrees centigrade that is heated and not vaporized because it's at a different pressure. So here you can heat steam further by adding energy to and make it superheated, but nonetheless we have learned about the latent heat of melting of ice, latent heat of vaporization of water, and so on. So these are important properties. Latent heat of melting is of course the energy needed to break the molecular bonds that hold the water molecules together in an ice crystal. Remember, we said they are very well organized, so you need energy to break those molecular bonds. Latent heat of vaporization is the amount of heat that must be added to the substance at its boiling point to break the intermolecular bonds and change it from a liquid boiling state to its vapor state. For water, that's 540 calories. You have to break all the hydrogen bonds. Remember, even if the water is boiling, it still has hydrogen bonds. Each molecule has to be broken from its hydrogen bond. So here you are doing it by adding energy, whereas in evaporation, you're going to take energy from other molecules and pull away one water molecule as water vapor. So that's a very different process than vaporization. So evaporation, vaporization are very different in terms of where the energy comes from. So evaporation cools the water, whereas vaporization is you're adding energy and creating hot steam.